First of all, welcome and good evening. What a pleasure to have all of you come. It is truly humbling to think how many of you drive to come to a meeting. So the pressure's on us, and I feel the responsibility that we talk about things that you want to talk about. We'll talk corn. I love corn. And we've had some unique growing season this year. All of us have a story. I visited with hundreds of you last night, and tonight already, a lot of you, and all of us have a certain story, don't we? So tonight, I'm going to use a lot of examples from our farm, and it's not because Greg and his team is so fantastic. It's just the data that we have, and I want to share the things we do, and a lot of you are doing that and much more. But my goal is that if you've taken the effort to drive here, you're going to think through your home operation, where you and your family live, and the way you do things, and hopefully you're going to grab some different ideas. And you're going to take those ideas, and they're going to take root when you get home. So speaking of taking root, fire up, let's go. We're going to do some ripping. So obviously this ripper has the bullet points on it. So it's got a 14-inch wing. We talk about it all the time. How does a crop put roots down? So it's doing a fantastic job. And he got her stopped right before we hit the door. So we'll take a little time here in a minute or two. We're going to rework the track. We'll get the planter out here, and we'll get ready to get it set. That tractor's going outside, so we might get her cooled down a little bit till we get him out. It takes about 30 seconds to fold the wings, so that gives us time to get the planter out. A little different meeting tonight. You know, in the winter meetings in the past, we do them indoors at the Yield Center. Pretty hard to rip on a concrete floor. So we had an association here of a friend that has this horse arena, and we said, why not? Let's see how much stuff we can do live. So everything in the building should run. So as soon as Kurt gets out the door, we'll have Jan redress the track so we can plant corn, and we'll get ready to go. That kind of looks like full spring tillage to me. So we think about the past season that we had in 2018, and I think these three pictures describe the many states that are sitting in this group. A lot of you told me here over supper that you had the wettest growing season in your history. Others of you from the south said that you started wet, and then it got extremely dry in June, July. And for those of us that live right here in the central part of Illinois, Indiana, and Iowa, we had perfect growing conditions. And so those variances happen every year. And I don't know how you and I predict what the year is going to be like. So what we're going to talk about tonight is how do you and I design a system that no matter what nature deals us, we're in a sweet spot. We can react. So let's jump in, and let's talk about a little bit in the past and what the next 5 years are going to look like. So I'm going to take you back to the changes we've done on our own farm in the last 5 years, because we've learned a lot. And it's those things that's helped Cindy and I and our family make a difference in how we farm and how we raise corn. And it starts with information. And sometimes it's hard as a farm family to get the right information. And you need to sit down with someone, if it's not yourself, and you record, and you look at all the data that you're doing in your farm, all the expenses, every penny, and you start to take a fine-tooth comb. Because what we're going to talk about tonight is lowering inputs and raising yields. As much as I wish I had the power to call Chicago Board of Trade and tell them that we need $4.25 cash corn next year, I can't move the bar. You just can't change it. In fact, I saw recently some articles from some ag econ guys, and they said this. They said most farmers, including Gregg, wish for higher grain prices. And we'd all say yes, we'd nod our head. But they said after they've looked at it for years and they did the studies, every time the market goes up, the farmer's net margin doesn't change. Because all the commodities, N, P, and K, diesel fuel, cash rents, John Deere combines, Case tractors, seed corn, they immediately, look what's happened just in the last 3 months of nitrogen prices. And so the minute we see a rally in the grain market, we see the commodities start to go. So the only answer that Tim and I, as we work at our family farm, is we need to raise more to overcome. But we're passionate on taking inputs down. So in 2014, I put up the exact amount that we spend on the things you and I know that it takes to raise corn. Then I went in the spreadsheet and the things that we've locked in, and we already know 2019 prices, what our costs are, and we've taken in the last 5 years our costs down 44%. And that's what's keeping us alive. And we're looking through it with passion. And so I'm going to show you some of the things that got my attention that I got a bullseye on. Well, you can see quickly we've taken seed and nitrogen down, and this year we're taking fall fertilizer down. And that doesn't mean we're not applying fertility. You can't rob the bank very long. All of us can have a story in our neighborhood where we know of someone that's basically just stopped spending on the input side when it comes to fertility. And it isn't long and that farm's going to crash. So, starting out, the one I'm most concerned about is our fall fertilizer price. It's painful. It's a price to us that I'm taking a look at and say there's got to be alternatives. Now, we're in an area where there's not much livestock. You probably noticed that coming in. There's two things you should have noticed when you drove in. Very few livestock farms and very few grain bins and farm dryers. You notice that? You just don't see them. And so when we talk about lowering our fall expenses, for us, we're taking a look at how do we manage and how do we achieve more natural products like manure. So at the dairy, it's pretty easy. We use a dragline system at the dairy. The problem is we only have about 1.7 million gallon, and that covers basically about 145 acres. So that's not going to do the whole farm. And you say, well, there's a lot of different livestock there. In our breeding program, there's probably some dry manure. And there is. And we're putting that on at 10 ton to the acre. We're following all the application rates. We know exactly what the value of that manure is. We test the loads. We test the liquid. So we understand what we're applying. And so we know we replaced $61 worth of fertilizer. So it leaves us a net of the livestock on about 385 acres of corn. We're $39 a head. Cash in the bank. And I like this. And so I challenged our family and I said, you know what? We're going to need some more livestock. So I have a young man that sells us DeKalb seed. And him and I are out for lunch, and we're talking about it. He says, you know what I really want to do besides farm and sell seed? And I said, what would you like to really do? He said, I want to raise pigs. I've raised pigs in the past. So we started taking a look, what would it look like to have a relationship where we could put some buildings up, where we have enough acres where we can put a dragline system in. And so these buildings are 2,700 head buildings. Each of them do 200 acres. We're fortunate. We have 850 acres here, basically, in almost one location. It's about a mile between them, the two fields. So we started with 3 buildings. And we said, is this an opportunity for us to put in more manure? And so it's something we're looking at, and we're saying, how do we continue to do this? Because I don't think they can all be down in North Carolina. I don't think we can raise all the pigs for the food chain all in one state or 2 states. That's when we start to get environmental issues. But I'm here to tell you, you don't make friends when you start putting up hog buildings. The field that we picked, there's no house within a mile of that location. And it lit them up. And we did everything exactly to regulation. And so you don't make friends, but at the same time, it was the ag world that was probably the most upset. And my question to them is, if we have a young farm family that's trying to get started, that's trying to build into the ag world, I'm willing to stand behind him and help him. Yes, you say, well, Greg, yeah, you're helping him, but you want the manure. Absolutely. But I'm excited about some of the potential that we have. So in the future, we'll have one more building there, and that's going to take care of that location. Other things that we see in the spreadsheet that concern me, and that's storage cost. When do you sell your grain? How much do you and I want to take off the $350, $370 that we sell for? And so for several years, Tim and I have had detailed plans drawn where we said, let's look at building our own grain operation. The problem we have in this area, we got an extremely efficient co-op. They're the best in the world. They pay tremendous patronages back. We get 26 cents a bushel back in patronage and drying. And so they charge us 30 cents to store till July. We looked at building even a very economical system, and it would cost me 33 cents to put it in each year to pay for the system. The real problem we have, and if any of you come in that direction, you see they built a brand new facility. Look at the minutes. At 6:57, we checked in the scale, and we checked out at 7. 3 minutes a load, day after day after day. My semis are in and out in 3 minutes or 4 minutes. And so I look at that and I say, how can we build enough drying capacity to keep up? And so, and by the way, this must have been the last load of that field because I can't believe we'd be over 80,000. But we just did it to get out, to get done that day, I'm sure. I'm running the combine. I'm not in the cart. You're running the cart, right? Why are you smiling? You better not be 87. I've had people ask me, you stay legal, Greg? I say, oh, yeah, I think we're running the money. And then I look through the tickets, and I'm like, oh, yeah. I'm sure it was last load. So when we talk about marketing, Tim and I talk about all the time, and Andy and our family, and we look at the past history, and there starts to be trends. And you start to see in the last 10 years, from April 1st to July 1st, 80% of the time, the high came in that. If you and I are going to hit that high, what do we have to have? And somebody's probably thinking a lot of guts, because you're going to sell aggressively before planting. You're going to start to sell crop. If you say you're not going to store, then you're going to try to hit that May, June, and then you're going to deliver in the fall. You're going to have it sold in that time frame for fall. And so you look at the past year, look how the lines line up. It's almost verbatim. 2018, this is corn futures price, and look exactly when you should be selling. And so I've worked hard with our family to say, look, let's position ourselves that we have confidence that we're going to raise really good corn. So that means we do a lot of tiling. We pattern tile. We put in irrigation on flat black ground that looks like this. Because what are we trying to do? Do we say that we need more farms? They just sold a farm not far from some ground, a mile from some ground we have, 13,800 in a 330 corn market. I look at that and I say, what am I doing wrong? That's a 1.9% return. I'm like, what am I missing here? So I don't know if you're young sitting in this crowd, you need to go to the bank and borrow more money to buy more ground, or do you just need to improve the ground you're on? Maybe you need tile. Probably about $800 an acre to put the pattern in. Maybe you need irrigation, probably about $900 an acre to irrigate. But if you have those two scenarios and Mother Nature decides to get cruel, you got your hand on the switch and you start to make things happen. Is it perfect? Absolutely not. But you got to have courage to sell. So here's where we sold. So you can see where we sold, and we're not perfect. I'm not trying to put this. I said we're going to share our numbers. Doesn't mean we're great. We're gutsy. We had about 70% sold till the yields come in, and then we ended up being 50% sold because we weren't selling as high as maybe we should. We figured 217 bushel more in a conservative, and we ended up over 260 for farm average. So those are things that all of a sudden you got more grain to sell. So on January 2nd, we cleaned out. So I don't think we're going to build our own elevator, but I think we're going to become very aggressive on selling at the right time so we don't pay storage. And so it takes some courage. A lot of you in here, last night I had a farm family sitting right here in the front row where these folks are, and he told me they only raised 200 acres of corn in Wisconsin. The rest they raised potatoes and cabbage and peas and green beans and sweet corn. So he's a specialty guy. And he said, in all the days of your precision, you never build a very good seed meter, because he said, I need to read cabbage seed, and nobody can read cabbage seed coming out of the planter. And I said, nah, that wasn't, because it's smaller than dust. And so that's a problem. So we're going after specialty crops saying, and it's a small percentage of what we can grow. I don't know if I've ever done a farm meeting where somebody doesn't say, Greg, all you're talking about is taking yields up. Well, I'm talking about taking inputs down and yields up. It's the opposite. Those two arrows are doing something you say in your mind, I don't think that's possible. Oh yeah, it is. We're going to prove it tonight. But they say, if we keep taking yields up, you're responsible for $3 corn. No, that's not what it is. These guys here, they control the marketplace, because they're about the only ones in the world that make canned pumpkins. If you have pumpkin pie at your mom's house on Thanksgiving, it'd probably come out of this area. So what do? They harvest just the right amount. What do they do with the extra? Don't worry about it. This year, 1,500 acres rotted in the field because they said, if we make any more cans at Kroger, the price is going to go down. And they're not going to let the price go down. OPEC does it all the time. How well does that work for them? Not very well. Back in the 80s, they thought they could get 80,000 of farmers with a lariat around us, and they were going to control how much we raise. Doesn't work, does it? Doesn't work in Canada on the dairy quotas. I got friends at dairy with us. They hate the quota system. You can only raise so much milk. After that, they dump it. And so I don't think the answer is for us to make sure that only we raise 148.8 bushels on every acre. I think we go for it. We know what it's going to take to feed the world. We know that 9 billion people are going to happen. By 2045, it's there. We have to have a farm average of 300 in America, not 176.4 or whatever it would be this year. So specialty crops fit into our family. This is low acres. but we sure like seed corn because this gives us courage to sell because this is a contract. If you know you got 245 bushel guaranteed, it doesn't take much of a scientist to sell then, does it? And so this fits our program very well. So all of our best acres go into this type of production. So I'll show you the splits. 2014, it's just me, but how bad is this speaker? Is it okay? Don't say that. Say Larkin, you're in trouble. Last night, it worked much better than this. It's just cutting out continuously. 2014, no secret, Gregg likes corn. 55% of our acres are in corn, 24% in seed corn, and 21% in soybeans. You look at 2019 splits, you see a lot more beans, don't you? And last year, the same way. You only see, what, 4% on pumpkins? Because that's about all the acres that are available. They're only going to raise 10,000 in the whole area, and last year they cut that to 5,000. They still threw away 1,500. And so I watch it with interest. What about profit per acre? So this is our profit per acre. Last year, per acre, this is where the money come from. And so as we move forward and we look at our spreadsheet, we say we've got to lower our costs even more. This is one I got my eyes on. Besides fall fertilizer, I told our team, we can take out more money out of the checks we write for genetics. And so we test. That's this year's trailer of seed, and we test them. 26 different genetics go in. They go in at 2 populations, and they go across corn on corn and corn on beans. And we're wanting to know exactly which ones are paying the bills. So we set out with a goal that we're going to cut our genetics price, our inputs on corn this year. And so by doing that, we said we got to know facts. So this is our variety plot this year. You can see the top genetics, 26 genetics later, you can see its yield. So what is it? From 268 to 300. So what do we got there? 32 bushel difference. Who wants to plant the one on the far right? Well, not me. So then we put back in the list price for these genetics. And I look over at the right, and these guys didn't pay their way, did they? What are they, over $400? And they're the bottom end of the plot. That's a problem for them. And so we take it a step further. And we say, let's put in the discounts. So this is the volume discounts that you and I would get. And so you can see it here, what that would look like. And so now you still the green line is yield. The bottom light blue line is actually what our farm paid for it. So without question, we're shifting more to conventional and double pro. The yield's there. We test it. And we know where the yield's coming from. So as they do the Smart Stack technology traits in, there's a yield drag. So if you're going to start to cheapen up your genetics purchasing, you're going to have to become very good at scouting. Because what you've done already, you prepaid that to Monsanto and Pioneer and fill in the blank, Steins and Whipples and all the seed companies that are out there. When you write that check for Smart Stack, that basically says you don't have to leave the house. You just know that it's getting taken care of. Now, I don't believe that, but that's what a lot of people think. So you look at where we put in the conventionals or double pro, and we added another $23 of insecticide. So now the green lines are all the conventional and double pro. The blue lines are Smart Stacks. So you look over here on the right, and you can see there's some problems there. So at the end of the day, we said, well, let's make a chart with the gross return per hybrid. So right here, you can see little hybrid M, which is conventional corn. Look at where his price is there. What is it, below about $130? And so that's for the bag of corn. Divide that by 2.3, and you can see the per acre. Look where M went. It went to the head of the pack. So not only is the cheapest corn per acre, It was second in the plot for yield, and it topped the family for profitability. So these are things that we're always looking at. At the end of the day, we took $18 an acre out of our seed purchasing across all of our corn acres this year. And that's serious money. And so you start adding it up. We take it out of the fertilizer. We take it out of the seed. And let's keep talking about where we start to really pinch our pennies. Soybeans, I've told you for years, and all of a sudden they hit $10, $11, they become less of a weed and more of a crop, didn't they? And man, have they yielded in the past. Now we're in an area where conventional beans make a lot of sense, and there's quite a premium. So this year there's $1.30, and you can see our cost per acre for seed. You can see our extra chemical for conventional over a Liberty, a Roundup, or dicamba. You can see that we spend another $12.85 an acre, but you can see we get a $1.30 premium. So if you do all the math, at the end of the day, we make $90 more an acre on a conventional genetics than we do on a Roundup Ready or Liberty. So then we have to look and say, well, what about water hemp? What about the challenges that we face in this area? And so what it's forced us to do, we went back and we said, all right, we got to rip. Those acres are going to get tilled in the fall instead of no-tilled. We'll bring in the 875 that you just saw here run through. We'll rip those corn stalks under. It pains me to say it. We'll come out in the spring and use a soil finisher. I already understand that we're setting in a soil density layer, but beans don't seem to mind because we're going to do tillage instead of a burn down. We're trying to lower costs. And so it's been very, very profitable for us, but we can't make that happen everywhere because we got so many seed acres, and seed corn has water hemp. That's just the nature of the beast. You take corn, they chop off 18 inches, and some of our females only this tall, and heaven forbid 30-inch rows yet to boot, like that wide. And I mean, you can actually walk down them. And you look at that, and you see all the sunlight in the ground, you have to wonder why you got baby water hemp and all kinds of weed pressure coming in the end of July. And so it's hard to come back into those fields with conventional beans. So but let's talk about when do you plant them? And it looks to us like we've watched this really close, and you heard me say last year, if you want to add 10 to 12 bushel to your beans, the simplest thing in the world to do is plant them early. We tried all the different foliar feeds and all the magic in a bottle, and I can't get it to ever repeat itself. But this repeats itself. So we got one planter. You can see me planting beans here, and it starts first, well before corn planting. I had friends that planted beans in March, got 4 snows on them, and they yielded 98 bushel. Last night I had a gentleman here, 3rd row, said, Greg, I planted beans in March. They got snowed on 4 times. They went 103. I like that. I'll take some 103. I didn't have any beans go 103 as a field average. I had a lot of beans on the yield monitor that were well over 100. So what do we mean by early planting? Why does it pay? Because you can trick beans with sunlight. You can trigger them, and they're going to set more pods. So it comes down to saying, well, I only have one planter, then plant beans first. Wait on the corn. Listen to Justin, what he's going to tell you about starter fertilizer. You plant your beans first, you'll still get a week ahead on your week later on corn. If you use starter on it, it'll advance it 5-6 days right out of the gate. That's why we talk about starter fertilizer. So you can see here we got a planter that's built for beans. It's a 72-row twin 20. It pulls like a boat anchor. That's why we got a big tractor on it. We went out, we started on April 25th. That's the first possible day I could plant here. Now that's not early. Normally we're going by the 14th of April. But we rained, it was cold. Actually on April 19th it snowed and we had frozen ground. So we started planting. Take a look at what 2 weeks earlier did. And you go in the middle of the chart there, and you can see the difference. And so as the later we planted this year, the yield naturally dropped. And so for this year, as we did all the data, we went into every field, every genetics, it was 20 bushel for the early beans over the late. And so if you take it, that's $180 an acre. And you start looking at acres, and don't tell me you can't afford another planter. And you say, well, I need another tractor, I need another man. I understand. I went on Tractor House, just pulled up a nice little 16-row of central fill 2014 planter for $72,500. In the last 3 years, it would take 600 acres to pay for that planter, and it's paid for. How many of you are raising 600 acres of beans in the room? Yeah, lots and lots and lots of you. So this year, and I know we're going to freeze some beans off. And Mike, I don't know what our replant policy is, but it's good, right? We just had 350 people witness that thumbs up. I'll call you if he doesn't deliver. So if we freeze them off, we'll replant. So we're going to run 2 planters on beans early, and the third planter is going to do corn. My goal is, in the first 10 days, to get all the beans planted. Corn can go later. The May corn by far out-yielded the early corn. Our best field was May 8th. So these are things that we think about. These are things we need to challenge you on. But I well realize that maybe not everybody in this room has opportunity for specialty. So let's talk corn, because this gets my motor running. You look at this field here, and there's some things that should stick out to you. If I was walking with you in that field, the first thing I would look for in your program, do all the rows line up from the tip to the butt? You look at that far left ear and your eye follows it down. You look at population in this field, and it's talking to us. And we got kernels right here. What do we got? Maybe a ½ inch of a cob out? That's just picture perfect. And so how do you and I achieve? They said, well, Greg, everything was perfect for you in this field this year. It wasn't perfect for us. So that's what we're going to talk about. What do we do when things aren't perfect? How do you and I put together a system that isn't going to fill this building with equipment that every other year you hook onto a different piece? And it comes to understanding what drives corn yield. There's 3 things. There's rows around, there's length of an ear, and then the really big one is test weight itself. What is the kernel dimension? How much weight does it have in it? And the scary thing is, you and I, as much as we want to blame nature, we need to look in the mirror in the morning when we're shaving and own up to the fact that we own these 3 things. And we realize that there's all kinds of opportunity. When we're talking rows around, and you think about it, your corn's at 18, 16, heaven forbid, 14. If there's stress, because when does that happen? Early. Boot high corn. At V5, we set how many rows around this corn's going to have. Every 1 row, this is basic, I know you know this, is 10 bushel. If I walked in your field with you and we see this corn scrambled, right here, it's 18 for the first inch, and then it went to 16, 20 bushel. $70. Greg's fighting to get 18 on genetics and 40 here and 30 here, and you and I give up $70 and we don't even blink an eye due to the way we manage that field, the stress that comes in early in that corn. So we are responsible for it. Length, we talk about it all the time. If you and I run this plant out of nitrogen, we're going to blow off kernels. Very common to take 8 kernels off the top. At 6 bushel a kernel, 50 bushel. I've seen many a scenario. We have 70 bushel, 50 on the top, 20 on the way around. And the farmer's looking at me and saying, I don't think I like this genetics very good. Really? Whose fault is it? And so there's opportunity, and there's things that you and I can do. So let's move ahead and say, what would we do? How would we design a system that's foolproof? And I'm pretty passionate about nitrogen on the planter. You'll never convince me that once and done in the fall, the best thing that ever happened to the Corn Belt is it got winter early and we stopped all the anhydrous from going on full load. You'll never convince me. How would you ever know? In November, pick an imaginary date. We talk about wishing we had a higher grain price. And we got farmers that are out there on November, I don't know, say 7th. And they do a once and done. In other words, full meal deal. And they check the box and they say, we got our nitrogen program put to rest. How do you know on November 7th what the moisture, temperature is going to be on June 25th, July 15th, August 3rd? You probably need to work for the government. If you're smart enough to tell me you need 235 pounds of N to equal 242 bushel next fall, you're sharp. You got it going. Because I don't believe you know. I didn't know. For years we worked on this and we couldn't figure it out. So let's talk about some of the different things that happen. You look in the center and we talk about starter fertilizer, and Justin's going to go into detail about some new technology. How do we simplify and afford putting on starter so we get a plant out of the gate really, really well? And then if we're not once and done and we're side dressing, the picture on the right is a really easy answer for fine-tuning the right amount. So at this day right here, life is good. It doesn't get any better than this when you're running a planter. Maybe harvest. But that day that you're running that planter, there's tremendous enthusiasm and hope for what? The perfect yield. In your mind, you think, last year we raised 238, this year it's going to be 249, and at this stage there's nothing to stop it, is it? Everything's going in really well. Now we realize that corn just grows. It doesn't matter where you, I'll guarantee you we're 1,000 miles apart in this room. Well, we have someone here from China, so we're more than 1,000 miles. So corn just grows. And if you and I are going to say, let's make that corn really happy corn, and we think about a root system, and you say, well, I'm from Nebraska, Greg. It's different than this dirt. Last night a guy said, how do I take this home? And I had to smile because corn grows the same at his house as it does at this place. And so we think about corn growing here and your crown root coming out, and you can see it up there. A couple weeks ago, we had Ukrainian farmers in Morton I was working with. And in Ukraine, the corn grows exactly the same. So if you and I are going to say, let's fine-tune our dollars and let's raise yields, where would you put nitrogen to make really happy roots? And we talk it all about the time. That planter pass is free. Over the last 7 years, we banded nitrogen of our planter. And last year we jumped in and banned it, and we said if we're going to make it perfect, we would put a band of nitrogen 3 inches each way from that plant center, right where the kernel is. Now, early on, this little guy has seedling roots that came out. These guys don't have a lot of capacity to pull up much nitrogen. It's not until your crown roots start to come out that positive things really start to happen. How late is that? Corn this tall. V5 corn lives off of mama seed. Until mama seed dries up, corn doesn't have a root system. There's no crown roots here. It's trying, it's putting them out. What happens at V5? How many rows around you have? Do you have happy corn or do you have sad corn? You stress corn early and run it out of N, and that's a problem. So we're going to come in and put band nitrogen 3 inches each side, and I'm only going to put it 3/4 of an inch deep. And there's a reason. We want to make a very simple attachment. We want to work with nature. What's nature give us in the spring? Water. And the minute this nitrogen band starts to get moisture in it, it starts to precipitate down through. It's called dilution, and it's diluting, and it's going down through. Now when the baby roots start to come out of the crown and they hit this, salt is no longer a problem. It's been diluted, and it's moving down through the profile, and the roots are growing right in it, and they just go crazy. I mean, the hairs on those roots just go nuts as they feed on that early nitrogen. So we talk about it all the time. If I was going to put a seed in 1 3/4 inches, I would put a strip of nitrogen, in this case 32%, on each side of it. We know that moisture is going to take it down. What would that implement look like? It would look like this right here. We've only added, what, 5 inches in the actual row unit length? And we got what? We have wheels, 8 inches diameter at an angle, spring-loaded. Why are they spring-loaded? Why are we only going 3? For years, the industry said 2 by 2. That's been an industry standard for years. 2 inches by 2 inches is where the nitrogen goes. Do you realize how much downforce it takes to put a disc opener on a planter unit in the ground 1 3/4 inches? I know. For 19 years, that's all we thought about was planters. And if you're telling me you're going to put 2 more discs in and you're going to force them to go deep, your row unit's going to come out of the ground. You will not have enough bar weight to hold it in. You say, well, I got delta force, I got air force, I got lift bags, down bags. I get it, but we want every kernel to be the right depth. 1/8 of an inch different in seeding height can bear them out. I've seen it. A planter comes up for 1 or 2 seeds and then goes down. Those 2 guys are spindly, half the diameter, and they're barren. So we said if we make spring-loaded and we hit those really hard soils or a rock, instead of the row unit coming up, we just let the nitrogen disc come up and right back over it. We said it'd be very simple just to put, like we used to do seed firmers, and just put some nylon seed tube guides in there. Now you watch it run over residue and through the field, you can see that we're putting the nitrogen under the soil exactly at 3/4 to 1 inch deep. So let's take a look at that running. Andy, fire up. We'll take him by us, and we'll plant some corn. We got the track just the right distance that we can make the turn. That planter is spinning around on itself pretty hard on the inside row unit. So as he comes by, you can see the bandits in here. You can watch it up on the screen. We got a GoPro on it. You can see that we got drag chains behind it. But as that row unit comes by, you can see where it's working. You can see the nitrogen tubes right in there. And so we're on each side, we're putting that liquid down in there. So as you see it run, very simple concept. We talk about doing no harm on things that we invent. These discs will not collapse the top of your seed V. They're angled so the top of your seed V, where the dry dirt is, never falls down into the seed and creates an environment where you got seed and dry dirt. So we'll bring Andy here and we'll shut him down. And we'll take a quick look of Tim's iPhone. We'll put it up on the screen for you. We'll let him go far enough by that most of you can see. Let's just take a look. So we talk about having a spring-loaded disc. This disc has 3 settings. Notch 1, these are notch 2, and notch 3. So if you go in the no-till, you're not going to have a problem. They're adjustable. You can see here as I move it, you can see exactly how it's adjustable. The disc has got the ability to come up a notch 2. I hope I can lift it, Tim. I haven't had anything to eat yet tonight. Seemed to work. Look where the hose is. We talk about a hose guide down in here. And so this hose has got the capability to float. And you can see that there's pressure on it. But look down in here. I can stick my fingers right down in the true V. These discs have not collapsed dry dirt. You know, for years I get that question. And guys would say, what about case gauge wheels on my Deere Kinsey planter? And I'd simply look at them and say, if you have a really dry season, I wouldn't do it. Really wet, yes, they had a relief in them. But what would happen in a really dry season? There's no true V action gauge wheel to hold that trench open, and you would lose as many as 2,000 to 3,000 plants due to dry. On the back side here, we got some chains. And you can see there's a difference between these two rows. In the cast row here, this chain comes around the back, and it's dragging. I love them. They cover up a multitude of problems. You and I make mistakes, the chain closes that up, and we get fantastic germination. But over here, for years, as we bought chains behind planters and you run the Martin spikes, one spike or two, the chain on the end rows would flip up and catch on the spike. And then it would drag. And that means you got to get out and run around the back. So a simple design, we made it so the chain can never get in to the spike wheel. And so as you look across here, we got lots of different types of closing wheels. Schlegel, we got a 15-inch Martin against rubber. Got furrow closer, of course, some rubber. And so those are things that are out there. Go ahead and fire up, Andy. We'll take you back home. This year, we added some model expansion. We got the 7,000 row unit, which is the same identical as a Kinsey 2000. We got the Kinsey 3000. We got the White 9000, and then the Harvest International row unit available. But you say, well, all this about nitrogen, Greg. Does Bandon really pay? Like I told you, it's a free pass. You and I are going to cover every row with seed. Why wouldn't we put on some tanks and a nitrogen applicator to do it? This is down south of us, probably about 100 miles. And they just had two fields side by side, one with Bandit, one without, planted the exact same day. And they're just showing you that there's 2 collars difference. In other words, that corn just got out of the gate a little bit faster. So we do a lot of trials, and you can look here, and you can see where we use 200 pounds of N. Broadcast versus with Bandit. Bring my chart out, and we can talk about it. So you look at corn on corn, and you see that number underneath there, and you go, come on, Greg. Same genetics, side by side. The only thing difference is we use the Bandit, and you say there's 23 bushel there. Let's talk about how is that possible? Where would 23 bushel come from? Well, we realize that on corn, you have a lot of residue here. And we talk often about these little guys. And these little guys named are Mike. I really like Mike. Microbials, good guys. See, when you tell me you're once and done, you don't believe in bacteria. Because you're doing it all. You do all the heavy lifting yourself. And you wrote a check to the supplier for all the nitrogen. In our program, we're going to put on 80 pounds of N, 40% is what we're looking for. And of course, we always put in sulfur. We got thiazole in there. So in our case, it's 23 gallon of a 32 plus 2.3 gallons, so always 10% of a thiazole, gallons, okay? But these little guys are out there. What do they use? Their job is to what? To eat all the corn stalks. I've told you before, it takes them 5 years to eat an adult plant. Mike and his team. How many are there? Lots. Lots and lots and lots. Let me give you a number. 36,000 pounds per acre. For you guys that raise cattle, that's 36 1,000-pound steers per acre of every corn you raise. If you didn't try to cut your fall expenses and you haven't put any limestone on for 2 to 3 to 4 years, and your pH has dropped. This is a 6.4 pH. What if it went to 5.7 pH? How many steers per acre do you think are standing out there in the same exact cornfield if you let the pH drop? Somebody shout out a number. 10, 15? We went from 36 steers to 1. 1,200 pounds of bacteria per acre and a 5.7 compared to a 6.4. These guys, you haven't heard this word for a long time, give you free. I like that. Free nitrogen. How much? 80 to 100 pounds. So now you start to see why we get excited about putting on a Bandit. So we come out here with Bandit and we get 80 pounds on, and then what are we doing? Something that's hard for Greg to do, we wait. I'm not the most patient person in the world, probably can sense that. And so we wait. How long do we wait? Until we get corn head tall. Why do we wait that long? Because corn only needs 25% of its N up to this point. And then from V11 and 12 on, it needs 75% of its needs. But the neat thing is, in the last 3 years here, these guys are working their hearts out. How do we know? We test. So you look at this field, let's say the road's here. Now on our team, the wees go out and pull the soil samples to put in the soil scan. They're going out pulling a sample 12 inches deep. So I'll tell the team, we need to pull nitrate samples today. What that means is, Greg's not, but they are. You know, you like to be one of Greg's sons, so. And Megan gets to go along too with Andy, and they go out. But we don't send them to the far back side of the field. We only have, 3, 4 different soil types in these fields. We'll come in here just off the road, and we'll pull a sample on June 7th. And I'm looking for a number on that field. And so on 6/7, it says 19 parts per million of nitrate. Okay? 1 week later, on 6/14, we come in that same spot and pull in that same area, and it says 18. Let's do it different. This is 17. Didn't start out the right number. It says it went up 8. In other words, it went up, and we got corn growing. Corn that's almost waist tall. How can the number actually go up? These guys, every time they feed and die, they give ammonium. They become the jet fuel for that corn plant. And so for 3 weeks, you'll see corn actually go up with a soil scan. You're gaining nitrogen from the good boys. This is why we're waiting. If they want to work, Greg sure doesn't want to write a check. And then all of a sudden, you'll see it start to go down. 15, 13, and when it gets 9 parts per million, 10 is a magic number. When it gets to 10 parts per million, Jan starts the Hagee, and we start applying with a Y drop, and we start putting nitrogen on to keep very, very happy corn, because we understand we want to save every kernel. And so these are things that we just do. I don't make the team go into every field and pull samples. If Paul has an Ipavia, Paul, and I have an Ipavia, and we're 3 miles apart, I'm pretty sure our numbers are almost identical, especially on our own farming operation. I'm only going to check 1 or 2 fields. Then if there's a problem, we'll go out and get to work, and we'll look deep. So if residue drives microbials, and this is a no-till field planted in beans this year in Iowa, and you can see a difference. On the right, they use chain roll, a concept that we said, what if we can make the plant disappear in 2.5 times faster than 5 years? What if we can make it disappear in 2 years? Look at the residue on the left, a John Deere intermeshing corn head. That's what they sell. The only difference on the right was we had chain rolls in the head. The whole purpose of chain rolls is to make the microbials eat residue faster by chaining in 7-inch pieces, and every inch we make a fracture so that the microbials can get inside and eat it. And we've added different corn heads. We used to be Deere only. This year we've added Case, 3000s, 4000. We've added gearing off North Star. And so there's some other things that are out there. So you're sitting here and you're saying, well, I kind of like this nitrogen thing on the planter, but where in the world am I going to carry it? I probably would have told you 4 years ago that Greg and his team were going to design nitrogen tanks for tractors. I'd have laughed and I said, I don't think we're in that business. The reason we're in this business is because you and I have to learn where to carry it. I looked at what's out in the marketplace. Not only is it expensive, but it's really, really wide. My heart pumps enough when I take equipment down the road. So we told our engineering team, we went 700 gallon. So for us, that's about 30 acres to the fill. And then we're stopping again. But I said it cannot live a ½ inch even wider than the duals from the factory. And I want plenty of space in between so I can see out. And I want to make sure all the weight's not on my front axles. I want a large percentage of the weight to be on the back axle so I don't start to tip this tractor ahead and compact. And so the 700-gallon 360 tanks come to be, and they've been a lot of fun. But at the same time, you're sitting here and you're saying, you know what, Greg? I got a 24-row planter. I invested in speed tube, because I thought I need to get more done instead of buying a second planter. Probably should have bought the second planter and put it in beans. Another story. So now you're going 10 mile an hour, feeling good about it. So if you're going 10 mile an hour for a 60-foot planter, you're planting almost 60 acres an hour. So every half hour, you're looking for a truck and a road that you can get a tube hooked to you. So a year ago, we introduced a concept that everybody laughed. I mean, it got more laughs and giggles. At the farm shows, they just stand in the aisle and they point. And they say, that's the craziest thing I've ever seen. But when I was in high school or before, we started buying grain carts to chase combines and nobody laughed. We said, why would we stop a combine? We said, that makes no sense to unload. So we unloaded on the go. We unload on the go every tank. I don't know if this year I can remember one tank where I sat on the headlands and unloaded. We catch them all. So why wouldn't we take a planter where we're using starter and nitrogen and start to nurse that planter so we're 30% more efficient? And we never stop the planter. On the right day, you can't get enough planet. Agreed? But boy, on the wrong day, do you ever wish you broke down? Every one of us can tell you which day not to plant corn on the previous year. We all know. 2 years in a row, it was Mother's Day. We called it the Mother's Day Massacre. It was painful. You didn't want to plant any corn that day. But on the right day, you don't want to stop. So 30% more acres out of the same planter done right. Let's fire up and take a look at it. So you can see we're demoing an open gator. We ran 2 on our farm this year, 1 cab, one open. We got funnels on both sides of this planter. So it's pretty easy. We're going to come up here. We're going to connect. We got 300 gallon here in this tank. We've added an extra axle in the back to help. You can see we got a little 2-inch pump here, gasoline engine running. And so this has the ability to pump 100 gallon a minute. So in about 2 minutes and 48 seconds, we can move 300 gallon over. So we're going to go ahead here on a tight turn. We're hooked in. He's fired up. You can see the water running into the tank in the top. So he's now pumping nitrogen over in the planter. The planter guy doesn't even know he's back there. He obviously knows he's back there, but he's looking in the rearview mirror. But he's paying attention to 2020, all the things that are going on. And so as we watch it, you say, well, that's a pretty sharp arc. How is that planter and gator going to stay connected without leaking fluid? So we've made some design changes. Last year it was hooked up with a magnet. This year we've changed the connection point. Right now, Noel's not, his foot's off the gas. That planter's dragging the gator. So it's just pulling along. He's not touching the string wheel. If you look at the string wheel, he's just letting it run. So you can see it here. Now we're not pumping wide open. So that's not pumping 100 gallon a minute. You can see the nitrogen tank and the planter filling. So as he goes around the corner here, we know you're going to put multiple products in. We got an air tank. You can see it down right here beside the motor. He's going to take and empty that whole line. And so you're going to see him stop. You're going to see him now hit the air. And so he's going to discharge and blow all that material out. So he just did. Okay, I'm behind, aren't I? And so you can see that he's now aired. He's going to go ahead and unhook. It's an air cylinder and a latch system. So he's unhooked. We're going to bring the plant around and stop it. We'll show you the hooking system. And you say, well, who in my operation would drive it? Well, last year I had a 75-year-old gentleman driving my semi for liquid. He jumped in that gator the first field, and he never looked back. It's extremely easy to run. If you can point the boom at the funnel, it's going to connect. And so we'll bring it up here and take a look at it. We'll have Andy stop. So we have a funnel on both sides. So depending upon your farming operation, so you could either put starter always on the left side and nitrogen always on the right, or in this case of an open cab, we got two funnels, so whichever way the wind's blowing. It doesn't take a young farm guy to long figure out, I want to be on the right side today because the wind's coming out of the west and all the dirt blows away from you. So it works pretty good. Tim, why don't you get in close and let's talk about what we have here. So we have a little air cylinder. Go ahead and latch it, Noel. Pull it back.
Oops, sorry.
Wrong button. There you go. So look here, you can see, go ahead one more time. You can see these little fingers are unlatching. And so once you come in and spring load it, they're going to catch right here on this heavy duty ring. This assembly is pulling off of the actual row unit. I'm not going to suggest that you take a 300-gallon of nitrogen and let it drag the gator. It's very easy to keep up. We ran a lot this year at 8.5, mile an hour, day after day, with no problem at all. Tim, show them the gasket in here that's actually in there. Use your finger. You can see the gasket that we're bumping up against, and so that's what's making that seal on a sharp turn. I'm not going to suggest that you move nitrogen as you go around a tree in the middle of the field. I mean, it's going to be a lot of work, harder than it needs to be. You notice that we removed the box here on this row. There's a reason. Because we're turning so sharp, you would have bumped into the actual seed box itself. And so this is kind of a unique situation. We just wanted to show you. How about back up just a little bit, Noel? Andy, I think you're free to go. You can park back. So we talk about how do you run your operation for what we do on the last load of that field. And he's going to start to go. My truck driver is going to leave. And so he's giving him the last load of nitrogen. And so he's going to head back to the tank farm to load up for the next field. Try to think here where I'm at, right there. So you would put the pin in, and you would hook it to the back of the planter. So the planter operator finishes the field. He hooks the gator up. He's got a winch. He can raise it anywhere that he wants to raise it. He can raise that up, and he can pull it to the next field. By that time, your truck driver is going to be back. And so he gets to the field. He's going to unhook the gator. If he's got enough nitrogen, he can start the headlands. By that time, the truck pulls up. He puts some fills of a 3-inch pump, the gator. Truck driver jumps in. Otherwise, he's just sitting on the headlands, listening to the radio. So I want to put him to work. So anything I left out, Noel? Why don't you head on off the track, and we'll see what happens. So we're always looking for ways. How do you and I become more efficient with the same team that we have? How do we get more out of everybody throughout the day, and how do we keep planters running? So that's some of the challenges we have. We're going to take a 15-minute break. We're going to let you stand up, use the restroom, get something to drink. When we come back, Justin Cook is going to talk to you for 26.6 minutes. That's what you told me? Close. 26.6 minutes. He's going to talk to you about the value of our Dash and new Echo technology, and how come we believe in starter as passionately as we do. Justin worked with me for years at Precision Planting. He's the grandfather of 2020. That's what kind of a super mind he has. Him and Tim designed the field view. So Justin's going to come back right after break, take 15 minutes, and we'll meet here again soon.
Well, while everyone's gathering, I'm going to get started. I always include a few slides up front that are not necessarily directly relevant to the topic, but it gets us thinking. And today, this talk is talking about the first 5 inches of plant growth, the early life, And also, I just want to get you thinking in the world of time. So to do that, I'm gonna hail back to some experience that I had at former life before I got into biological side of farming. I was at Caterpillar. Before that, I was at the University of Illinois for 11 years working on lasers. And while I was at CAT, we were working on drilling the holes on fuel injectors with a laser. And we were using a laser, it was called a femtosecond laser. So this helps you get into terms of time. But to describe a femtosecond, you really have to think in terms of distance. So we all know that light travels, 186,000 miles in 1 second, right? That's 7.5 times around the face of the earth in 1 second at the equator, okay? That means in 1,000th of a second, light can travel 186 miles. So from here in Delavan, 186 miles will get you to Madison, Wisconsin in 1,000th of a second. Or Indianapolis, Indiana in 1,000th of a second. Or it'll fall short of Des Moines, Iowa by about 40 miles. Okay? That's how far light can travel in 1,000th of a second. Now, in 1 nanosecond, that's 1/1000th of a second, light travels 1 foot. By the way, did you know that the nanosecond was defined in Chicago, Illinois? Argonne National Labs down there on the southeast side of town went downtown, and that's where the nanosecond was defined. It's the unit of time from when the light turns green to when the cabbie behind you honks his horn. That's 1/1000th of a second, okay? That's how far light travels in 1/1000th of a second. Now, we were a femtosecond, so that's, if you go down to 1,000th of a nanosecond, that's a picosecond, okay? And in that time, light travels 12 thousandths of an inch. That's 3 thicknesses of paper, okay? And we were working with a laser that the pulse duration was 150 femtoseconds, so that's 1/8 of a picosecond. Light travels about a half a sheet of paper during that time, okay? So even though it's a very small amount of energy, the denominator, the power is always defined by energy divided by time, so the time is really, really small, so it makes the power really, really big. It's like hitting with a big sledgehammer really fast. So the peak power during the pulse is 6.7 gigawatts, and we'd focus it down to a spot size about 1/4 the diameter of a human hair, and we'd create energy power densities that were orders of magnitude higher than the surface of the sun. We would literally rip electrons off the metal, and once the electrons are gone, then the nucleus is just kind of float away. And we'd machine these, we'd actually cut out those holes in fuel injectors. And there's actually no heat in it because you're just ripping it out. It happens too fast for heat buildup. So what does that have to do with planting corn? Right? Well, it's a loose affiliation, okay? But we are going to be talking about pulsed systems today, and we are going to be talking about time. Where and when do we need fertility? And I'm talking about now fertility on the planter pass. Okay, this talk is narrowly focused not on your global fertility program, but just on the planter pass. And a lot of times on the planter pass, we use words like pop-up and starter, right? And now there's a new trend happening where we're putting nitrogen on the planter pass. So I'd like to use a couple different words rather than startup and starter and pop-up, and use the word intimate placement and strategic placement, okay? Intimate means exactly that. You have to place the fertility intimately close to the seed. And strategic placement, you don't have to. So to summarize some of the descriptors that differentiate between the two, in intimate placement, millimeters matter. Okay, a few millimeters or some amount of millimeters can make a difference on whether the fertility is effective or not. Millimeters matter. Nextly, when we're talking about intimate placement, we're talking typically about immobile nutrients. Things like phosphorus. You put them, you inject them while you're planting, and they land and they move a little bit while the water is, whatever the carrier is, and they attach to the soil and they don't go anywhere. The roots have to go find it, okay? We are dealing with high risk in this intimate placement. You're significantly altering the chemical environment as the seed imbibes water, and as those little seedling roots start to migrate out. If you alter the chemical environment, it's a risky business that we're going to look at in this talk. It's high cost of fertility. The cost of pound of phosphorus and nitrogen is really expensive on your in-furrow products. And it also, there's just an uncertainty on if there's value in it or not. There's so much uncertainty, and it's just unknown potential, both in a positive and a negative. You don't know if you're going to hurt your seeds. You don't know if you're going to help your plants. You're not sure if you're going to get a financial return on investment. And there's a whole lot of potential that is being worked on right now that we're going to devote a little bit of time on just the whole biological world of what potentially could be happening out there. And lastly, for the intimate placement, it's for now. You are placing that fertility very close to the seed because you want, as soon as roots come out, you want them to smell it, taste it, and get it. They need it now, okay? In contrast, strategic's very different. It's not millimeters that matter, inches are acceptable, okay? You're not talking about immobile nutrients, you're talking about mobile nutrients. Things like nitrogen and sulfur. Things that attach to water and they go down and they get transported with water. Mobile nutrients. You're talking about low risk. You're going to put, it's low financial risk, it's low agronomic risk. It's inches away from anything that really matters, and there's no financial risk because everybody's going to put nitrogen every year, right? It's just when and where you put it. Low cost per pound on the fertility, and everybody knows the potential of nitrogen. There's very little uncertainty on putting nitrogen on corn, okay? And lastly, when you put that on the planter pass, you're not going to use it right away. It might be weeks before that fertility comes into play, okay? So, intimate placement, strategic placement, okay? I'd like to just talk about this particular topic about the riskiness of fertility. And to illustrate that, I want to just show some work that Jesse and Zach did a year and a half ago, where they planted about 10,000 seeds in our R&D lab area, in little tubs, okay? And what we did is we planted at different application rates of gallons per acre, and we also planted at different dilution. So on the left 3 is 2.5 gallons per acre, the middle 3 are 5 gallons per acre, the right side 7.5 gallons an acre. And with each of those, we did 100% chemical, 1034-0, 50-50, and 25-75. We diluted it with water. So that's why you see the one that's 100% always has less liquid that's been applied to that row. And by the way, this really comes home to roost when you started getting out a syringe and realizing just how little liquid 5 gallons per acre is. It's 1 drop per inch, okay? It just isn't much. And when you start having to look at this little 1.5 cc's in a syringe, and you've got to spread that out over 16 inches, it starts to come home to roost of just how little that is, okay? Then what we did is we made 2 tubs for each application rate, and then one we would leave just as is. We pulled the soil out of the field. It had good moisture. We planted into it. And then the other one, we'd wait a day and a half, and we'd give it 0.4 of inch of rain, right? Because when it comes to chemicals around the seed, water covers a multitude of sin, okay? So we just started looking at some of these seedlings as they began to grow. And I'm just going to show you pictures of different application rates at different dilution rates, and you can get to see that here we have 2.5 gallons per acre, and on the right, it's 100%, and then as you move from right to left, we dilute it more. But we're always putting the same amount of chemical per foot. We just apply more liquid when we dilute it, okay? So dilution is a good thing. If you look at, there's down there at the right end, those seeds that were at 100% got retarded. It slowed down the imbibition of water, and the rootling, as the roots started to grow out, they were inhibited as well by that concentration of fertility. If you look at the stuff that got rained on, not near the effect. It's what you would expect. You go to 5 gallons per acre, we stunted the growth a little bit more. Okay, the rain helps it. When you go to 10 gallons per acre, we would just stop the growth of those seeds dead in their tracks. Okay? And even water didn't help it a whole lot. And as we talk to Ferry and other agronomists, this is a story that comes out. They can't figure it out. They have some of their growers that are putting on 7.5 gallons an acre of 1034-0 through a firmer, no problems. They have other growers that are putting 3 gallons an acre through firmers, and they have problems. It just depends on the amount of moisture in the environment when you do it, okay? And so whenever you put on fertility onto seeds, you got to ask yourself a question. Do you feel lucky? Right? I can always tell who's over 40 years old here. They remember Dirty Harry. Okay? So let's just talk about some of the risks and some of the trade-offs that anybody who either is putting on in-furrow products or thinks about it, there's several trade-offs, right? The first question is, should I do it? Should I even be putting in-furrow product? There is a number of growers who have done it and stopped doing it. And the number one reason that when I talk to people is we ran the numbers. It cost us $18 an acre to put it on. When we ran the yields, there was no return on investment. I added a lot of hassle, and I got a wash. So financially, is it worth it? It's a fair question. There's a trade-off. There's the certainty that you're going to spend the money. There's the uncertainty that you're going to get it back. Okay? How much should we put on? Should we put on 3 gallons an acre, 5 gallons an acre, or 7 gallons an acre? More is better, but more is riskier, right? Trade-offs. Should I buy low salt? Should I run 1034-0 or should I run 626-6? It's quite a bit less saltiness, but it's twice the cost. Brings me back to issue number 1. Where should I place it? Should I put it 2 by 2? Should I put it off seed with a huck step or a furrow jet? Okay, all of those come with placement and risk associated with it as well. And lastly, if I'm going to get into this world of biologicals, how do I know what is snake oil and what is the real ponies? Right? There's just a tremendous amount of research and products out there, and it's typical, right? Everybody claims 5 bushel advantage. Right? It's amazing how many bushels we could raise if everybody who claimed 5 bushel advantage could produce it, right? We could be raising 600 bushel corn, okay? So those are just some of the questions I think that we should consider whenever we're talking about in-furrow fertility. I want to just take a little bit of time to talk about this biologicals, because I think that as I listened to people over the last maybe 10 years, we have gone from being cynical to skeptical to hopeful. I mean, if you watch what Ferry's results on some of these biologicals, they're the real deal. When they're taking plants out at V6, V7, they're keeping right up with the other in-furrow products. So there are real work, and it has a tremendous amount of potential. And the nice thing about biologicals, they're harmless, right? They don't bring that risk that we're talking about, but they're expensive, okay? So just biologicals, this is what I've learned in the last year, and I'm very much of a layman at this point, so if anybody in the audience has better understanding on this, I love talking to people about biologicals because I think they're going to go somewhere, okay? But there's basically 3 forms of biologicals. There's bugs in a jug, there's bug food, and there's fungi, okay? So bugs in a jug is all about taking living organisms, living bacteria, and you might get a shipment and with instructions of this needs to be in the ground in 48 hours. You might get some vendors have a dry powder that you pop a little pocket in the lid, and that dispenses the granular down into the water. You give it at least 24 hours in a warm environment, and now it's ready to plant. It's got a 14-day window that you got to plant it, but it's all about putting bacteria right next to the seed. And the purpose, and that's exactly what Gregg's talking about when he talks about Mike, because it's bacteria that eats unusable forms of nitrogen, and then they die and they create usable forms of nitrogen. That's what mineralization is. So bugs are just injecting more bacteria right next to the seed, and bug food is just giving enzymes so that you give candy bars to all these bacteria that are already there, and they just start populating and growing at a much more rapid rate, okay? That's bug food. And fungi is what I've got a picture of here. These are the mycorrhizal fungi, and if it wasn't for those little critters, we would not have plant life. Those little fungi have a synergistic relationship with roots. The roots provide glucose and sugars, and they go inside the root, and they live off the root. And they expand out into the soil with very, very fine structure, very, very thin entities, and they draw in particles that the root itself could not draw in. So it depends on your soil health, and some of the older soils out east need this, and they respond to this much more than the more healthier soils in our area. Okay? It takes living roots to keep the fungi alive. That's why things like cover crops and no-till are promoted to keep your fungus levels high. Okay? Just a brief tutorial on biologicals. Okay? So, back to intimate placement. One thing that we noticed when we did the test plots that I'm going to be talking about in a little bit later in this talk is that you could begin to see a response versus the treated versus the untreated when the plants were this size. And if you notice, there are no crown roots on this plant, right? At this juncture, the seed, the plant is living off the seed itself, the starches in the seed, and it's starting to draw in moisture and nutrients from that little radical root. So right now, the radical, when the seed first imbibes water, it expands, and the first thing that happens is the shoot goes up and the radical goes down. And then shortly thereafter, the 2 seminal roots come out. The seminals don't tend to bush up like what we're seeing here. So that's why when you're talking about intimate placement, it's really important that this radical root experiences the fertility. That's why 2x2 has a very dull response, because these radical roots never see 2x2. Okay, there needs to be the handoff, the baton of some in furrow, and then the 2x2 if you're going to use that technique. Okay? So what we've called around here is the zone of impact. If you look where fertility, when that plant is young, when that intimately placed fertility is doing good, it's when the plant is very young. It's so easy to get one growth stage or 2 growth stages ahead at this juncture if you can accelerate the growth when it's young, because the amount of uptake is very small. Okay? So I just classify the zone of impact as that 3 inches, 1.5 inches either side of the plant. You need to get fertility in the zone of impact. And it's not that the fertility outside of that zone won't get used, it's just very low return on investment. Okay, by the time the roots are getting to that, it's too late to really do its good. So that's the whole theory that we're working on, where we're developing this DASH product of injecting fertility just in that 2 to 3 inches right around the seed. That's where it does good. And that's where it has the high return on investment. Okay? So let's talk a little bit now about just the mechanical side of how do we get those little 3-inch bands, because it is non-trivial. Unlike lasers that have no mass, light has no mass. It's easy to get things started and stopped, but liquid it's not. So this is a high-speed photography of, that's 10 hertz. But to get that much water going, or that much liquid going, and then stopping it, and getting it going again, and stopping it, getting it going and stopping it, has really proved to be challenging, okay? So we thought this was gonna be a pretty easy project when we got into it, but it's not. But we're having good success. I'd like to just explain a little bit what, we had some pretty heated discussions in our whiteboard room on what does 15 gallons an acre mean. Okay? When you're putting a continuous stream, it's really easy. Your planter has planted 1 acre, and the tank has gone down 15 gallons, right? But all of a sudden, you start dashing 3-inch dashes, your tank's only gone down 7.5 gallons. So how many gallons per acre did you put on the field? 15 gallons an acre, okay? That's our definition. We did not put 15 gallons on per acre, but when the seed woke up and the roots started going out, the concentration it experienced was as if it had been a continuous band of 15 gallons per acre, okay? All we're doing when we're dashing is we're turning off the flow some fraction of the time. So we're down in Texas this past week. He's running 20-inch rows on 27,000 population. He's only putting a seed every 14 inches. Okay, so he's putting a lot less than half the amount. He's down to 1/4 of the amount of liquid that has to be delivered to the field, but every seed's waking up and thinking he put 15 gallons per acre along the whole way. Okay, so to illustrate that, this is the kind of flow rates that we'd be having at 15 gallons an acre. As we go from 4 miles to 6 miles to 8 miles an hour, we have to increase the flow rate. And when we start pulsing it, all we're doing is we're turning it off. So at 4 miles an hour, we're turning it on for 40 milliseconds, we turn it off for 40 milliseconds. So we turn it on for 40 milliseconds, we turn it off for 40 milliseconds. Okay, and we only have to get up to 0.3 gallons per minute of flow rate during that time. When we go to 6 miles an hour, now we've got to get a higher flow rate for less time, because we got to get that same injection of liquid out in less time, so we've got to go fly a higher flow rate. And when you go to 8 miles an hour, it gets really bad. Every 20 milliseconds, you got to turn that, you got to get up to twice as much flow rate as we were at 4 miles an hour. So I'm just say high gallons per acre concentration levels and high speed really get challenging to get that train moving, and to get it moving fast, to get liquid out the door, and then turn on the brakes and shut it off, and then turn it back on and shut it off, and it's challenging, okay? So how do you know if you're getting to those flow rates and back off and back on and back off? High-speed photography doesn't do it, because it's hard to tell a very narrow band of fluid versus the full jet. So we just came up with a simple force transducer project we did at Precision years ago on weight measurements. So we went out and went to Amazon, bought 15 scales. We're going to figure out how do they weigh 50 grams of force. And we took them all apart, and lo and behold, they all have the same load cell. Okay, it's that little thing you see in the bottom right corner. Little piece of aluminum machined out, got screws at each end, and a strain gauge on it, and that's what they use on all these little scales that you see that you get for $14 from Amazon. And what we did is we just screwed that in, cantilevered it, and then we shot the fluid at that red spot at the bottom right corner, okay? And that measured force in a really fast time. So what you see here, every vertical line is 10 milliseconds, and the orange is the plunger going in and out, opening and closing. And the blue is the force that's being impinged upon that little scale, okay? And this is what tells us, yeah, you're hitting and you're getting a nice clean pulse, and you're getting all the way down to zero flow and back up to full flow and back. So this is the kind of tools that we used. All that to say, this is not for boys. This is really tough work. okay? And it caused us to do two things. One, we had to make a valve system that was really snappy fast. We had to be able to turn on and off that plunger really, really fast. So high forces, okay? And secondly, we had to have a flow meter that did not have any moving parts. Okay, if you've got a turbine and you're trying to measure the flow rate that's going full on, off, full on, off, full on, off, it's got inertia to it. And so you just get a very much of an averaging effect. So what we've gone to is the Echo product that on the right, and that's an ultrasonic flow sensor. It's the same technology, it's the same transducers that are used in sonograms. Okay, when they put the little gel on you and then they move that around, it's a 1 megahertz transducer. And what that does is it sends waves down and then it sends it back, and the difference gives you, the difference time of flight gives you how much, what the velocity is of the liquid. You know, the cross-sectional area, you know, the velocity, you know, the flow rate, okay? No moving parts, very fast response. We can see starts and stops of the kind of time frame that we're dealing in. And then on the left, what you see, the dash unit is in the top is the valving system that's actually opening and closing, and then every dash unit has the Echo flow meter built into it. Okay, it's all an integrated system. Okay, so one other myth I just wanted to dispel is you'll see advertising literature out there about systems that can put injections 1/4 of an inch away from the seed. You dial it in on how far you want to be away from the seed or on the seed or just off it, and it can do that. That's the marketing literature. And the reality of it is that there's just first of all, the picture on the right is something we took years ago, and that doesn't really happen anymore. To get that amount of ricochet means the seed had to hit some mechanical ledge, which is a problem that was solved by John Deere with their transparent seed tubes, and then Precision back in those days we had Bullseye. We got rid of all those features that cause that kind of ricochet. But what you do get, if you watch every seed, is that they usually hit, on their way down, they usually rub against the surface of the seed tube between 5 and 7 times. And every time they rub, they get a little bit of a turn and they slow down. And they're airborne for a little bit. High-speed photography is wonderful to see this. And depending on how many times it rubs, depends on how long it takes to get down the seed tube. Typical standard deviation is about 6 to 8 milliseconds. Now, when you're going 6 miles an hour, 10 milliseconds is 1 inch of travel. So just natural variations could be plus or minus an inch when you include that and seed roll. So the reality of it is we're hitting a seed, but we really don't know where the seed is. We know where it is plus or minus maybe a half an inch on a bad day, plus or minus an inch. So what we've taken a tact is we're just going to put a 3-inch band of fertility minimum, and we're going to center it on where we think the seed is, so that when it wakes up, some of those roots will find that fertility, and they do a good job of, once they find the fertility, of the roots growing into it. Okay? All right, on to trial plots. This is the 80 acres. We had really one question to answer on this test plots. That was this. Is a 3-inch dash, if you're going to plant a seed every 6 inches, that's 34,800. If you're going to plant a seed every 6 inches, is it give you the same exact results if you only put 3 inches in that zone of impact and don't put any fertility outside of that? If you only put 3 inches, does it give you the same impact as if you ran continuous? That was the only question we really wanted to answer in this. And we ran 2-inch dashes, 3-inch dashes, and continuous to prove it out. On the orange, that was planted May 2nd, and the blue was planted on May the 10th. And then the green was filled in on May 11th, but that was not the starter plots. Okay, that was just to fill in the rest of the field. So there's 8 days difference between the early planting and the late planting. And I just want you to see that as you go to the visible imagery, you can see, this is from 5,000 feet. It's an Air Scout image, high-resolution image from 1 mile up in the air. And you can see that the north half, the early planting date, is greener, right? And there's also one little strip that goes across there where the orange is on the map on the right. And that's the early planting date, and that's much darker than the other strips. But you can also see in that red circle different intensities of green. Now it pops more when we go to the NDVI picture. And this is the area of the field where we ran 5, 10, and 15 gallons per acre local concentration at both the 2, the 3, and the continuous application. And we put in lots of check strips. If you look on the far left side of the picture, you'll see where those little red bars, those are the check strips. We ran 0 through a firmer, and we ran 0 with the huck step, and we did that every other pair. So we did a pair of those, then we did a pair of treatment, then a pair of those, and a pair of treatment. So every one that's red is a check strip. Because the truth of the matter is, when you do these plots, where you put a plot in what part of the field makes all the difference in the world. So you have to put in lots of check strips if you're going to come to any conclusions. Okay, so we put in 50% of the field is check strips. Okay, the summary of it, we went out when it was this tall. You know, as you can see in this picture, we went out when it was a little bit taller than knee high, and we took it to harvest. And I'll tell you the short story. The numbers are right there. That the 3-inch was as good, and we don't even understand why it's better, but it's as good or better on all metrics, on all the biomass metrics and all the yield metrics. Okay? And I won't go into the details, the numbers are there, but that's the short story for this year. Now, the interesting thing was, this was only true, starter only really had an impact this year on the late planted corn. Right? Because there's 2 ways that in-furrow products are going to make money for us. The first one is if the seedling goes through a immobilization where it gets cool, and it goes through an immobilization event, and it gets starved on phosphorus, it will make decisions to retract on girth. Okay? Phosphorus stress is very critical when it's deciding kernels around. And that's one way that you can buy insurance if you're going to plant early and you think that there's a chance you're going to go through some thermal cycle, some cool weather, then starter's going to pay off. Because that plant will continue to grow and will continue to put on full potential of kernels around even through those immobilization events. That's one way it pays off. Number 2 is it supercharges plant growth. You could see from those strips and from the NDVI that where we put in-furrow products, the biomass accelerated much faster. Typically 1 to 2 leaf stages over its growth cycle, depending on how much you put on. For the early planted season, early planting window, it didn't make any difference, right? Because all it did is it just got to the finish line sooner. But the stuff that was planted on May 10th, it did make a difference because it needed to get those solar collectors out much faster than the other plants. It caught up with the early planting of the non-treated. So that's the think through. I just want you to think along with me on what's the good use of in-furrow fertility. If you're planting early, if you see a cold window, you're gonna get it. If you have soils that are cool and moist, you're gonna have a good return. If you have soils that are dry out fast and warm up quickly, you're probably not gonna see a return. If you're planting in early and like this year where May just looks like the 10-day forecast is always warm and sunny, you're gonna get very little return. If you're planting late, you will get a return because you'll get that plant up to V7 a week earlier than if you didn't put the in-furrow fertility. So reduce stress during the immobilization events and supercharge the plant growth to get those solar collectors out sooner and faster, okay? All right, 3 concluding slides. Bottom line it, hit the zone of impact. Don't worry about outside of that zone of impact. That's where you make the money by getting the fertility in that red box. Number 2, if that's true, let's cut our costs by 50%. If you're putting $18 an acre, that's $9 an acre of direct cost savings. And I think that it allows us to go to more Cadillac solutions and put in other things that we wouldn't have put in if we're only paying half the money. It enables dilution. If you're putting in only taking half as much product to the field, then dilute it 50%. It's clear that A, dilution reduces the risk on the seed, and B, the number one thing that causes uneven emergence is uneven ingestion of water. So if you put a lot of water around every seed, you're improving the chance it's going to get up and fire and get to out of the ground at the same time as other seeds. And 3 and 4, open doors for biologicals. Okay, and I think I've already covered the other 2 things. We want to eliminate phosphorus stress so it chooses a high girth, and 2, we want to get the solar collectors out sooner so that the plant is converting sugars. Okay? These are trends that we see. I'm going back more now to a higher level of both strategic and intimate placement. These are 4 trends that as we look at what technology we should be building for planter-based fertility, these are 4 trends that we see. First one, we think that there's a movement of people putting nitrogen on the planter pass. We continue to get a high smiley face index from people we talk to who made a decision to put nitrogen on their planter pass. There's just very few people, when it comes to in-furrow, 50-50. When people who put on nitrogen, they never look back. It's the best decision ever made. So we think that we're going to go from 15% of the planters to 35% of the planters in the next 5 years are going to put planter-based nitrogen on their planter. Okay, it's a market we're trying to capture. If you look at all the products that were coming out, the Bandit, the Sprint, it's all geared towards that. Even this, the Dash and the Echo Valve, all about controlling flow and measuring flow. Okay? The number of delivered gallons to the field is going to go up. Both because people are going to put, instead of putting 10 gallons of nitrogen on the planter pass, they're going to put 25. And things like Sprint, they're going to take dilution and deliver more gallons. That truck that sits at the side is going to be filled up more often, and it's going to be delivered to the planter. Our job is to make it frictionless and cost-effective. We think that in-furrow products are going to go up. The dollars per inch around the seed area is going to continue to go up. With biologicals and other things coming on, there is a huge amount of investment being made right now in the research world. Both the large companies of Monsanto and all the universities and small startups there's a huge amount of effort going on right now in the biological world. So we think that the cost per inch is going to continue to go up of in-furrow products. And lastly, just prescriptive. There is a world of prescriptive that different parts of your field need different recipes when it comes to in-furrow products, as well as nitrogen. So those are 4 trends, and the features that I'll recap our features for the Dash and the Echo. Snappy flow control. We got to be able to control it on a sub-millisecond level. High instantaneous flow rates. We got to be able to get up to 15 gallons per acre at 8 miles an hour. And lastly, that we're going to have instantaneous flow measurements, and we do that by having no moving parts. Okay? I think that brings me to the end, and I'm going to hand it over to Greg. Any comments, Greg?
Thank you, Justin. We talk about this little plant. So you come out here and plant it early, and she starts to go these little seedling roots until you reach 65-degree soil. There's no phosphates available to that root. It's tied up. It could be there for 10 days, and it only soils get to 55 to 60, maybe 60 degrees. Until you reach 65, it's not going to start to light up the things that Justin's talking about. So that's why we make sure we have the insurance of starter. We don't know the day of planting what the next 3 to 4 weeks looks like. And number 2, Justin, and you did it so well, I think about starter as much as 5 days in maturity. So if you've been planting a 111-day corn, You use starter, you could go to 115-day corn and have the same response. So those are things that are out there to think about. So I really appreciate, we've used starter. It's not an option for us. There's several things in our program that are just given. When you go to my cost analysis spreadsheet, it's in there. So let's keep thinking about how do we continue to improve, though, in a lot of variability in the farming world that we live in. And we talk about a sprayer and its value. What kind of opportunity does it open up for you? You say, well, Greg, I'm farming 1,200 acres, and I'm using a custom applicator to do a lot of my work, and I get that. But they do a really good job, and there's some really good ones out there, and I happen to have one in this area. Not only is he a good friend, but he's absolutely point on, and he doesn't make mistakes. And when you call in, they work you in some way possible. And so as we looked at it, though, we realized after 3 to 4 days of rain, when everybody finally lights up, it's kind of a rush, isn't it? Who's going to get spread? How are we going to get 28 on ahead of whatever you're doing? And so there's always that concern. He was good enough to share with me, he kind of looks at it in 3 different levels. So we look at level 1, that's where you have everything custom applied or you're pulling hot loads out. And you can see the full services that he has, Saudi services, agronomic services. Level 2, you basically are doing all the self-applying yourself. You own your own sprayer, but you're getting the pumps and a lot of the advice still from him. And then level 3, where you start to pick up a 40% savings, basically you're doing your own work. And yes, there's lots of opportunity to save a lot of money on chemical and to save a lot of spreading application costs. But with it comes responsibility. Number 1, to your people. My guys are like my family. Jan is really, really special to me. So when we started talking about doing all of our own chemical application, I immediately said safety first. And then second is risk of misapplying. We have 6 different crops that we farm with. That's 23 different recipes of chemical applications that we keep track of. I'm probably over 55 fields. And so we can't make a mistake. If I custom apply for Paul here in the front row, and I make a mistake, my insurance covers it. And they pay Paul. If Greg makes a mistake and sprays the wrong chemical on my own acres, there's no insurance. And so as we talk about a pretty good-sized chunk of change that came into our bottom line by doing our own spraying, along with it came risk. So I started to research, in my research and Aaron's research, my farm manager, we said, let's build our own semi. We carry 6 mini bulks of different chemical. We obviously carry 5,000 gallon of water, or it could be starter, or it could be nitrogen, depending upon where this semi is going. But in the center there, you see a Surefire, quick draw. And it's designed with a computer that keeps you from making mistakes. And so when you pull into that field, if you know what field you're in, and you know what crop you're planting, it's going to measure out to the nth degree the right amount of recipe. They're all pre-programmed, you check them twice, you make sure it, and it literally changed our lives. Not only does it keep you very safe because you never touch any chemical, it's extremely accurate. So much so, we run 2 sprayers. We got comfortable enough that truck was going between a bean sprayer and a corn sprayer, all at the same time. So the first thing it's going to do is put in about 100 gallons of water. It's going to slow the pump down automatically, and it's going to measure each chemical in one at a time to the nth degree. Then if you told it that happens to be a 1,600 gallon Hagee, we run at 1,598 total gallons. It's going to rev the motor up, and it's going to immediately load that sprayer. So in about 7 minutes, you pull up, that computer is going to totally load you, and you basically did one thing. You push the start button, and it takes over from there. I'm sure there's possibilities for error. We think about it all the time. We put a hose reel on that's electric, a 75-footer. we got an air hose, we got a garden hose, we got hand washing water. So we try to take and look ahead. That obviously brought us to where we said, we're going to need to start to build our own farm storage. We've added to it since. So now we've added 3 more large tanks to this pad, and we've taken the water tank outside of it. And so it's starting to open up an opportunity. Once again, here we put electronics. You can see him standing there. He's on a digital pad. He's telling it which product he wants. It's all driven by air valves going through a manifold. It's a 4-inch pump that pumps 600 gallons a minute. And so it's going to load that 5,000-gallon trailer in a hurry with the right product in the right spot. And then it's going to have an air system, and it blows it all out, so the next time you come, there's 0 contamination. So those are things that open up opportunity, but the main opportunity it opens up is that now you have the ability to buy a commodity at the right time. Just like you sell a commodity at the right time, now you can purchase. And we're a lot luckier than we're smart. So we really increase the size of our storage, and we can hold all of our needs for our farm, and we were able to purchase it in at 32 cents. When I talked with Mark the other day, he says, Greg, we're going to be at 54 cents this spring. And so it looks like quite a bit of savings. So you're sitting there and say, well, I don't know if I want to build a concrete container and put in 6, 150,000 gallon of 28 and 30,000 of thiazole and 15,000 of starter. Well, you can put a plastic tanks in. Now, you might not be able to store as long. The EPA has a lot of regulation, but it comes down to saying, where can you and I make a difference? Yes, there's costs up front, but if you're fortunate enough, as we were, we paid for the system in 1 year. And so those are things that we take a look at. But we go back here and we say, we've talked about girth. You just heard Justin talk about it, rows around. We know that you and I own the length. It'll pollinate 48, 46, many, many years. We'll pollinate them. And then how we treat our systems approach is how many we're going to retain. Yes, weather has an effect. I'll be the first to tell you that hot nights are really going to hurt us. We talk about warm nights. 2011, we've lost 50 bushel out of our crop. Why? We had 35 nights in a row over 80 degrees. I'd feed cows late at night. I'd look at my iPhone, and I'd see it was 84 degrees yet at 10 o'clock at night. Cows are panting, corn's panting. If it's 78 degrees, we talked about how you're going to create this huge solar reflector and the sunshine on that leaf, and all day long it's pulling water up, a massive amount. In central Illinois, it's a 1/4 inch a day. This year in central Illinois, we hit over 6/10 a day, almost 3/4 of an inch. That's Texas. Our Texas farm every day pulls up 3/4 of an inch of water into the corn plant. Can you imagine that? Why? Because we're 103 degrees. At night it gets down to 58 degrees. We're in the high plains. We have 50-degree temperature swings every day. Very, very low humidity. Everything's irrigated. If it's not irrigated, the weeds won't grow. It's a beautiful thing. Our corners, all you see is rattlesnakes. It's just the way it lives. But if we get 78 or below, when it turns dark, immediately that corn plant, by the way that God created it, it takes all that energy that went into the stalk, every node, it starts at the bottom and packs the Walmart shelves to the top with energy and calories, and they all flow down to the ear. Unless it's 81 degrees, nothing goes to the ear, and the plant digests all that energy to stay alive till tomorrow. In return, you start to blow off kernels. So there's only 2 ways to lose kernels. It's either Gregg, by not having enough nitrogen, or it's the good Lord, and he says we're going to have a lot of temperature. Most times, it's us. And so understanding how much it takes to finish the race is crucial. None of us know. And that's why we talk about split application. being able to come in and react a little bit later in the year. 30, 40 days after planting can be huge. And so let's take a look at it. Where have we come in the last 5 years? 2014, I'd use Ken Ferry's recs. And Ken would write me a nitrogen rec for side dress. And it would come in and it would say, you need to put on 90 pounds as side dress. So a side dress, it called for 90 pounds of N on an Ipavia soil type. Gregg would look at that, and I'd say, Ferry, I know we got a lot of yield potential. I would take the 90, lick my finger, hold it up in the air, and I'd say, I don't know where he's getting that number. Let's put on 110. Why did Gregg want to put on 110? I sure didn't want to run out. And so we were just guessing. He had science. He said it's taking 1.1 pounds of N to equal 1 bushel. And it did. And it does. That's science. You don't change creation. That's what it takes. What you got to think about, though, is these guys. And if those guys are out there working for you, and you have a system to go late in the season to put on nitrogen when corn's this tall, all of a sudden, you start to turn the vacuum sweeper on to free change and money back in your pocket. And the 0.7 is huge. The last 3 years, we don't put on over 180 to 185 units of N. Last 3 years, running 2015 different. We scheduled 180. What happened in 2015 in Central Illinois? It rained like it did in Minnesota. It rained and it rained and it rained and it rained, 9-inch rains. I was out in Boone, Iowa this fall. Farmers were walking up to me and say, you know what we had? We had a 13-inch rain in 2 days. And then 2 weeks later, we had 11 inches. That's the truth. And it looked it. It made me sick to drive around Boone this fall. I can't figure them out. I asked one guy, he was pretty bold, he was a nice guy, and I said, can I ask you just a personal question? What have you done lately? His corn, all the corn there, when you drive to the motel or drive around the show site, this tall and bright yellow. And everybody's telling me, well, you don't understand, Gregg, we've had a lot of rain. I get that. I can look at the weather state, I see you had a lot of rain, but what did you do after that? Nothing. I said, where have you been? He said, we gave up. What do you want us to do? Put some nitrogen on. Ferry was out in Algona, Iowa, and he said, well, they took the Y drop and went into head-high corn and put out another 60 units of N, 70 bushel more. For every pound of nitrogen, take an imaginary number of 50 cents. They raised $3.50. Now, I'm not a mathematician, but I can make that work. And so you never give up on a crop. And out there in Iowa, they did. I don't understand it. They didn't go out and they didn't try. And so I never give on a crop until it's just absolutely finished. And then I willingly accept what we got. But 0.7 is huge dollars. We can't change the board of trade price, but we can change the way we farm. And so for the last 3 years, a lot of our fields this year were 0.68. 0.68 of a pounds of N equals a bushel. And so that's the kind of numbers that we're talking about. Is it hard? No. This young man, this is his exact yields. His agronomist said it takes 1.1. So his yield goal was 230 in the black there. He was shooting for 230 bushel corn, and he made it. He nailed it perfect. The agronomist put on 255 pounds to make 230 bushel corn, and he did it. And I can see the agronomist going, oh yeah. But the problem was he bought a Y drop and a Hagee, and he put on 75 with the planter. Then he weighed it, and he measured, and he said, you know what? I don't need 255. All I need is 180, which is 0.7. And not only did he save that money, he raised 11 bushel more. He himself told me, Gregg, $80 net per every acre of corn in my pocket. 1,000 acres, $80,000. Don't tell me you can't take her to Florida. Don't tell me you can't buy a new pickup, put in kitchen cabinets. This is life. And it's not hard. I had a grower yesterday, Iowa. 25 years of feedlot. Puts it all on the same acres. He said, I got fertility like crazy. And he had his 360 dealer with him. And their year was pretty wet out there. What happens in a really wet year? Mike dies, no oxygen, saturated soils. So Mike's got to start from scratch. Mike would start his population back up from zero. These are little baby Mikes. These were big Mikes. They're starting to grow. It would rain. We'd kill Mike off. He has all the fertility in the world and manure, no biological activity. The corn's this tall. It was turning yellow. The 360 guy come in with his Y drop. They put on 60 pounds of N, and they harvested 70 bushel more. Sounds just like the exact plot what Ferry had, different part of Iowa. And the grower said to the 360 guy, how is that possible? I have so much fertility. Why would I need more N? Because of the rain that he had. If I was a livestock guy, and I hope to become one, in relationship building with others to get enough manure to cover our acres, I would put a bandit, and I would put 40 pounds to 50 pounds of N on, and I wouldn't look back. I got cousins and family in the crowd that have a dairy. I can guarantee you their fertility levels are through the top. They raise phenomenal crops for years and years and years of manure application. They bought a drag line now. Now they're spreading out a little further. But if they put a bandit on and put on 50 units of N, I don't think they'd ever look back. What are they doing? They're growing more Mikes. What do these guys use for fuel? Nitrogen. If you're having a rough growing season and you don't have a lot of Mikes, you've got to figure out a way to make them grow. And you've got to keep the corn plant happy. And so those are things that are out there. I get this question all the time, and guys say, yeah, but what about urea? I mean, urea, Greg, UAN, so we're talking about 28% or 32%. You know, they say, that's a lot of dollars. Urea is the way to go. And I always say the same thing, how are you going to spread it? And they said, well, for crying out loud, Greg, Deere's got a box you put on from New Leader that does a perfect job of spreading. And that's when my eyes start to squint a little bit, and I listen. And they say it'll throw 60 feet in a perfect even pattern, and it's cheap, and it works. And I say it could. I've been testing it. This is from Iowa Soybean Association. They went out. When did they plant corn? On 5/7. They put on 70 units. So on May 7th, they put on 70 pounds of N. Then what happened? On June 13th, they came back with a side dress of 70 units in. So they only got 140 on. They really had some pretty good corn. Well, they had 230 on 140 units. They're in a 0.6 club. But they said, we're going to go here, and we're going to put a fan spread of urea. And they put that out there. Then they said, over here, we're going to take a side dress bar, and we're going to put the colder on right in between the 30-inch row, right down the center. Then on the other test, they said, we're just going to take Y-drop, and yes, we're going to put nitrogen on top of the ground. So this is probably about corn about this tall, I'm guessing, just looking at the planting dates. What is that, a month and a week, 5 weeks? And you look at the numbers and you see that this is what, 25 bushel difference? You say, seriously? But it was cheaper. Why did this respond so much? This one's 8.5 bushel. So in other words, Y-drop beat it by 8.5 bushel, and you say, well, how's that possible? It comes down to understanding how corn plants work. Our 3-year national average is 6 bushel. It's because you take more into the plant. Tonight at the buffet, if all you'd have taken is 3 pieces of shrimp, Your belly's probably a little hungry right now. But hopefully you followed Cindy's instruction. If you saw the sign, you took 2 sandwiches, 3 wings, 5 shrimp, and then you went to the dessert table, right, Paul? Shake your head. Attaboy. And so Paul took in more. Y-drop gives you more in the plant. You get more what? You get more kernel depth and more kernels on. And you say, well, kernel depth, what's kernel depth all about? It's about keeping plants happy. I get this question all the time. Greg, you use fungicides? Absolutely. Is it in my budget? Yes. Right now, in 2019, I'm spraying every corn acre with fungicide. And you're looking at me going, well, how do you even know you need it? Oh, we need it. What's fungicide do? It makes very happy, healthy corn. It makes standability. It keeps corn leaves in a good time and shape. You come here and look at these guys, you're ruining the solar panel. This guy's supposed to draw in what? 1/4 inch to 3/10 of an inch of water every day. And you're just frying him with disease. And we come out and we said, well, why would you do that when you could take something as simple as undercover and spray from the bottom where all the leaf openings are, and you get more bang for the buck, whether it's soybeans, cotton. We've done it all. We do vegetable crops. We do corn. And it's all about coming from the bottom up. And so in my budget, I'm planning on spending at least $10. I went to the meeting the other day on Bayer. I think I'm going to spend $12.93 because I like what they had to say about DeLardo. So for Headland Amp for years, it's a great product. And we believed in it. We spread it. Last year, did a little research. We found Gold Rush, which is the exact same formulation, for $11.11 an acre. I could put on 1/3 more. 10 ounces of Headline, 15 ounces of Gold Rush. And I asked Ken Ferry, my agronomist, what that meant. He said, that's an extra week of protection. I said, I'll take 3 weeks of protection for $8 less or $9 less. And so we did every acre of Gold Rush, and it worked really well. When I was at the DeLardo meeting, they're talking about that has 2 different tank mix of action sites, and they proved over, I think it was like 105 or some just in Illinois sites, they yielded 6 bushel more. So for me, that makes a lot of sense. Because what we're talking about is that little pile of seeds there. I'm not very good at drawing seeds. That's a seed of corn. Man, a guy ought to be able to do better than that. That looks like a tooth. So I'm not an artist. Do you understand, though, the industry talks about 90,000 kernels per bushel? I agree with that. But what if we keep our plants healthy with fungicides? We put the right amount of N on, not too much, not run it out. What if we could get our farm to go to 80,000 kernels in a bushel? Bigger kernels, heavier kernels. You know how much yield that is? Free? 28 bushel for every 10,000. Those starter plots that Justin showed you, 67,800 kernels per bushel. $290 bushel corn. This here is 220 bushel corn. And you say, well, Greg, I want to be here. I do too. But it doesn't come free. It comes with management. And so those are things that we look at. Let's bring the sprayer out. Let's do it live. Let's show you exactly what Y-drop looks like going through very high-yielding plastic corn. We'll go over the mound. We'll talk about steering and boom height, guide and glide. And then we'll actually spray some wet paper, and we'll show you what undercover looks like. So guys, fire up the deer, and we'll come out. And so in our sprayers, it's hands off. We set our AB line, as our RAB line is set, those wands are just measuring against the corn plants. As they measure against the corn plants, they're changing the steering box in your sprayer. So it's a very poor man's steering system. We don't spend any money but taking that measurement, and we go up there to the globe and we change the steering to keep you always in the center of the sweet spot. And boy, does it make a difference on wear and tear. You run a wide drop or fungicide in tall corn for 12 hours and your eyes are about to cross, especially if there's a little bit of wind. So what else happens? How about keeping the boom the right height? So we're going to come out here. We're going to have to get him squared up. He's over one line too far. He's going to back up here once he gets his spread. He's going to take the center line right towards Tim. We're going to run it right up and over the mound. You're going to watch the boom come up. Keep the wide drops out of the ground. As it comes off the mound, you're going to see it come down. So the little tail you see hanging here on row 1 has an impact. It's also got one of those in the center boom, and it's got one in the far right boom. So we'll let Reed Gear get on his mark. He'll lower it down and enact it. So when we're talking about glide, we're talking about using the exact same height sensors, your sonar. All we've done is added some technology in the bottom. Your cab does not see a difference. So if I picked up on this tail, we'll see if he's got it on yet, that's going to go up. If I lower the tail, we fell down off the hill, it's obviously going to come back down. So we're going to let him run right down here. He won't be running fast. You're fine in the front row. So it's in auto mode. It's keeping the wide drops right off the ground. Looks like he needs to head a little bit closer to the crowd. He might make the hill. I think it'll work for him. I think he's going to hit it. Barely. I think these guys in the front row paid him off to stay farther west. Now you see the boom going up. It's keeping it up as it comes down off. You're going to see it start to come down. Yeah, he made the hill. See how the wide drops are coming down? Now we were at a very low speed, I will realize. So that's the thing that happened. So let's back him up, and we're going to run some water here. The first thing we're going to do, we got a board team. Our board team is going to bring all 3 rows of boards out, and we're going to have wide drop running active water. So we'll bring out the corn. He'll get on his mark. We got a team over here that's going to change the nozzles around to wide drop. So you'll see the water coming out of the hoses, and you're watching right at the base of the plant. You're going to watch the edge of the plywood there, and you're going to see exactly where the nitrogen's going to go. I get this question all the time. Greg, what if it never rains? Wouldn't I want to have a coulter in the center of the row? Well, if it never rains, the nitrogen that's 1.5 inches in the center of the row is not doing anything either. We've had a lot of plots that went 47 days without water with nitrogen on top that out-yielded the coulter, and we had a tremendous response. So looks like Tim's just fine-tuning the corn rows. This is why we wanted auto steer so bad. We said, man, this will be a piece of cake. If we can figure out how to get auto steer to work inside the building, we'll never miss. I don't know if Tim's happy or not. He's saying go that way. You okay, Tim? Yeah? It's strong corn. I sprayed it with a fungicide. It won't fall over. So we'll get wide drop running here. We'll get some water coming out. There we go. We're putting on nitrogen now. So you're going to watch it come through the corn, and you're obviously going to see that we're putting nitrogen right next to the root. It's not obviously sinking in. It's a hard surface, but you get the gist exactly. So whether you're in 20-inch rows, 30-inch rows, 38-inch rows, we have the technology that we can adjust where the hoses are in the whip. So we'll pull some corn out here. We're going to put some wet paper in. Here comes Barry. We got wet paper. We got wet paper stapled to the top and the bottom of each leaf. So we're going to look exactly what kind of response we get if we just brought a nozzle over the top like an airplane or a typical sprayer, compared to where we run over in here with the undercover spraying from the bottom up. So Lucas is putting his plant in. Maybe hang right at the bottom, Lucas. It's a little, they're a little weak. Go right down the bottom and push him in. Yeah, there you go. That looks good. So we'll have this fantastic team bring it back out. I never give enough credit to our 360 team. They do a phenomenal job. I love all these guys and gals. So the first board, it'll be 15-inch nozzle spacing, spraying 20 gallons to the acre, and he's just going to run through the corn with just the top nozzles. He's going to go right here in the middle. He's going to stop. We're going to quickly flip it so we got top nozzles and undercover, so a total of 4 nozzles running, and we'll see what kind of impact we have in the corn plant itself. Now, you can see that we don't have a lot of leaf structure, so the top nozzle is going to go really low. So we'll get the sprayer running here. We got Reed, one of the engineers in the sprayer, does a great job. Make sure it's running. There, he's got it running. You can see the mist. So he's going to roll through there. Looks like we're going to make it. He's spraying it. I agree we're a little slow today, but we're safe. We're going to stop. We're going to change them all so that we have both top nozzle and the 3 nozzles pointing from the bottom up. Now, if I was running this corn today, I would probably move my undercovers down a little bit. I told them this is normally where you would in a healthy crop, where you would spray them. They'll double check themselves. Barry, you happy? Everything look good? Fantastic. We'll get our guys out of the way. And we'll fire up again. Now you're going to see these nozzles running. You're going to see the spray coming from the bottom. So we'll let Reed get started. There we go. So now we're going to go in that crop whether we're going after insects on the silk, whether we're coming over the top. So we're going to have Tim come up here with his camera, actually his iPhone, and we're going to take a look at what we have. So Phil's got on one hand, he's got what we sprayed over the top. So Tim, let's just take a look at this one. It's obvious that they did a pretty good job. This thin of a leaf, you can see the different structures. Everybody's saying, but look underneath, Tim. Let's take a look on the back side. Look at the back side of this leaf right here. Top, no question we got some. How about this guy? I believe there's one speck here. Top looks really good. This guy, top looks good. Bottom nothing. Let's take a look at undercover. So Barry's going to hand me undercover. So we got the top. And then we start looking at the bottom. You can see it there. Got good coverage there. Good coverage there. We soaked him there. Got coverage there. The very bottom leaf didn't get any on the bottom, but we got some all the way from the top. So we're simply, this is just basic. We're just saying, let's just do a better job of application. And it's things that are there. So we got the sprayer shut off. We're just about finished. We're going to have Jan climb up in the combine. We got 40 feet of corn there and 4 rows. On the 2 rows closest to us is a standard John Deere OEM. It's got the intermeshing chain roll, or not chain rolls, intermeshing stalk rolls, and it's got the deck plates set down tight to 2. On the other side, we have the yield saver brushes, and we got chain roll. We want to show you what it looks like, the chain residue. In other words, to let microbials get into that stalk and quickly start to break it down. So we'll get him fired up here. He's going to be running 2.3 mile an hour. Head speed is 530. Get the head speed set where he likes it. There he goes. So you can see him harvesting now. So he's coming through. And we just missed the speaker. So we got a team of 8 people, and they're going to stick a flag in where every kernel is. We'll get him shut down. And we'll let that team go to work. So they're going to move all the residue outside of the rows. So you can take a time over here and we get finished. You can just walk by, and they're going to start sticking flags in at every seed that we lost. If we go back up to the screen, so we were taking a look there at the yield saver as they ran. It's just simply some bristles that are designed to fit right onto your chain, and it's been a very, very simple process. We already showed you what a test looks like. We did it for you right over supper hour there. And this is the difference. This is the OEM, and this over here is the yield saver. They had a container exactly in each of those PVC pipes. And so you can see the kind of savings that they had. And you can see it there on a previous test. Those are things that are out there. So we've talked a lot about what's next. How do you and I manage for diversity? I realize that all of us live in different spots. But corn's corn. And you're going to have a hard time convincing Greg that your corn, wherever that's in Dakotas, in Kentucky. We had a gentleman here last night from Texas. How do you and I achieve really high yields by cutting inputs? And it comes down to management. It's not always about writing big checks. So I'd like to talk a little bit about the next 5 years. We look back in our operation. You saw we've cut expenses by 44%, and I'm going to continue to look at that. But I'm going to be honest with you. We got the dish rag wrung pretty tight. I'm not sure there's a lot more slop in our program. I'm going to continue to look. There's definitely slop in our fall fertilizer. No question in my mind, our plow down is too expensive. So we're going to continue to work on that. I think we can always find maybe better fungicides and a different chemical, recipes. Those are things that we have opportunity to. But nitrogen and seed in the 0.7 club, we're pretty tight. Genetics alone, I do not believe are going to ever get us to the sweet spot that you and I want to be. I took the top 10 hybrids in 2014 in our variety plots. Every year we do a detailed variety plot. It's the best day of planning we got. We learn a mountain from that. And so I took the top 10 hybrids. In 2014, they averaged 263. In 2018, they averaged 292. You divide that by 5 years, and we're gaining 5.8 bushel a year. And I'm telling you, just for Greg, I'm not happy with that. I don't think that's my goal for our family and the different farms that we farm. I think we got to take a dynamic leap ahead. When we were kids, I don't know if any of you remember, I'm probably showing my age here. We'd go to the grandparents every Sunday night. We had a ball. And some of my cousins are here. We would play Mother May I in the basement. And you would play, and they would tell you, the person out in front of about 15 of you would give you permission to take either a baby step, a regular step, or Mother May I, a giant step. And I'm sitting in the combine. And all year I'm talking to Tim, and I'm excited about 12 bushel, and 10 bushel, and 5 bushel, and 6 bushel gains, and all the different tests that we're doing. I'm not at all unhappy with a 4 bushel gain in something very simple. If it's a yield saver or whatever it is, I'll take it. But I kept telling Tim, we're missing something. We're missing something. I said, there is an opportunity here to take a huge step ahead. So in the next 5 years, our engineering team and Tim and I, as 360 leadership team of Justin and the rest, we're starting a yield campaign, and we're calling it 50 and 5. In 5 years, we want to go to every one of your farms, and we believe that we have a new approach that can take a 50 bushel step. And so this is what we're working on. And I'm excited about it. You know, a lot of you say in our lifetime we get the opportunity to do something really spectacular. And I was blessed. I had a chance to work with some fantastic people, Precision Planting, and we had a lot of fun. And I'll tell you, we designed the perfect planter. Now, you probably haven't seen it. They buried it when they bought it. But you see all the things that were in it, Delta Force and V-Drive and V-Set, and all that stuff was about the perfect planter. And so I believe that I am super fortunate because I'm going to have a second chance to do some amazing things. So stay tuned. We're excited that you're here tonight. I'm honored that you'd come. I want to thank you. I appreciate all that you do. I like the fact that you and your wives are raising fantastic young men and women on family farms. I would tell you right now, we interview a lot of young people. And if I talk to high school youngsters and they say, what field should I get into? I tell them the same thing every time. Here sits a young lady right here, agriculture. I talked to her and her dad. She's farming with dad. It doesn't get any better than that. When I look down the combine and I see Andy running the grain cart, that's a good day. It doesn't matter if the corn's slightly down. Things come and go. But young people are lifeblood. So I'm tickled you're an ag. You're feeding the world. I'm proud of you. I appreciate you coming. We're going to let you go. We want you to walk by the corn, take a look at the flags. I see a lot of red flags on the far side with Yield Saver. Probably something Jan did wrong. There's more flags, obviously, on the OEM side. I told Jan the other day we ran it, we had 12 red flags. I said, Jan, don't you get out of the cab if it's not at least 12 or under. Looks like he got out. There's more. Go back to the PowerPoint for 1 second. I know somebody's going to say it because I'm right and Tim was wrong. Tim loved this video. Do you see anything in there that would bother Gregg? So he's at the kitchen table, and we're eating breakfast together, and he said, Dad, I found the perfect video for the 50 and 5. And I said, there was one time where the elevator didn't close the gate on the hopper. I said, that's that one time all year. I said, they will see that. He said, they will never see that. Last night, guy sitting right here stands up and says, you would make a little more if you didn't slop so much. I said, I know that it's there. And we picked it up, the meat at the drone got done. So yes, there's 5 bushel on the lane. Sorry. If we could Photoshop that video, it would have got done. Tim said that's not possible. So there it is. Tremont Co-op, thank you. Jan's just standing there, looking at that 5 bushel ahead of his truck. He's about to run over it. I came around the corner. We're still opening this field up. I pulled right up there. We took a scoop shovel, threw them in on top of the Yield Savers, and there wasn't any corn underneath the head. So I had to point it out before all you guys come up and told me about it. I wanted to get ahead. So we can go back to the camera. Once again, thanks for coming. Drive safe and have a great week. Thank you.